and welcome back. Today we are going to continue our exploration of area. So we're doing a really great job of calculating the area of square and rectangle shapes, but not every shape is going to be a perfect square or rectangle. What do we do if our shape is a little bit different, like these? Today we're going to take a look at how we calculate the area for those things. Just a reminder, we now know that area is the measurement of the inside of the shape, or how much space the shape is going to take up. We know that area is measured in square units, so it could be centimeters squared or meters squared, and we know that to find it, we can either use multiplication or we can count up those square units when we can see them. So we're going to start by using shapes where we can see the square units, and then we'll move on afterwards.
Okay, so here we go. We're going to start with this green shape here. We know that to find the area, all I have to do is count these square units inside. So let's give that a go. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know that the area of this shape is 12. And we don't know if it's in centimeters or meters. It doesn't say, so that means it's units. And we know it's squared because it is not just a straight line. Let's try counting them one more time. We're going to use this yellow shape here. I'm going to get you to give it a try first, and then I'm going to count it after and see if we get the same. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, we don't know the units that are being used. They're mystery units. So we've got 15 units squared. Now, this works really well for these small shapes, but what happens if you get a bigger shape? A shape that you don't necessarily want to count all the little units for. I'm going to show you a trick that's going to come in really handy when we don't have the units visible inside the shape. So what I'm going to do is I'm actually going to break this up into rectangles. So if I draw a line here, and I draw a line here, oops, that's crooked, like that, I end up with 3 individual rectangles. It's going to make it much easier for me to find the area of. So for this one, I see 3, and this way is 4. So I know that 3 columns times 4 rows is 12. We go to this one. I can see, even though I crossed it off there, that it's 2 rows, 3 columns. 3 times 2 is 6. Then down here I see 3 rows, 3 columns. 3 times 3 I know is 9. So now to find the area of the whole shape, I just have to add those 3 numbers together. So 12 plus 6 plus 9. Oops. So we've got 9, 10, 11 plus 6 is 17. We know that's too big for the ones place, so we'll leave the 7. We'll carry the 1. 1 plus 1 is 2. So my answer is 27. There's 27 blocks or little tiny squared cubes inside the shape, which means that my answer is 27 units square. So I'm going to get you to give this orange one a try. It's kind of tough because you can't write right on it, obviously, but I want you to think about breaking it apart and finding the area. So I'm going to give you a few minutes to do that yourself. Okay, so I am going to find the area of the shape now. If you're not quite done, I'm going to get you to pause the video, and then when you are all done, you can click play and come back to it. So for this shape, there's a couple different ways that I could break it up. I see I could draw on this line right here and make this big rectangle and this little square. Or I could draw this way and make a slightly bigger square and a longer rectangle. That's totally up to you, however you want to. I think I am going to do it right here. We'll start with the little square first. So I see I've got 3 columns and 3 rows. So 3 times 3 is 9. And then here I've got 4 columns. 1, 2, 3, 4, 5, 6, 7 this way. So now I have to times 7 times 4. I know that 7 times 2 is 14. So 14 doubled is 28. Now I just have to add 28 plus 9. I know that 9 plus 8 is 17. Carry the 1, 37. So my answer is 37 units squared. Now there is one more way that you can solve this without cutting it up, and that is to make the shape into a square or rectangle. Now it works really well for shapes like this because I think we can obviously see all I would have to do is add a box in like this. For a shape like this, it's a little trickier because we'll have to add quite a few shapes and they're not all going to be perfect squares or rectangles. So this kind of shape, I really recommend you break apart. However, this shape, we can make it into a perfect square pretty quickly. And once we do that, then we just have to find the area of the big shape and the area of the little shape, and we're going to use some subtraction to solve it. So we'll do this one in blue. So we'll count our columns. We've got 1, 2, 3, 4, 5, 6, 7. And we know that up this side, I've already said, is 7. So then we would go 7 times 7, which is 49. So this whole big square, including this uncolored spot, is 49. Now, obviously that's not our answer because it includes this uncolored part. So what we're gonna do is find the area of this uncolored part and then subtract it. So we know that we've got 3 columns and we've got 1, 2, 3, 4 on this side. 3 times 4 we know is 12. So now we would do 49 take away 12. So 9 take away 2, 9, 8, 7. 4 take away 1 we know is 3, 37, which is what we already knew the answer was, 37 units squared. So for shapes like this, sometimes you might find it easier to just cut it up, or you might find it much easier to just add the missing section and then subtract it. Those are your 2 options. Now, obviously, a little bit more complicated than just counting up, but this is super duper important because you're not always going to be able to see our little squared units like what I'm about to show you now.
Okay, so this is where area can get a little bit tricky. We can't see our squared units inside this shape, and now we also don't have every single side length. You can see there's a few missing, this one and this one. So we're gonna have to use some problem solving so that we can find the area of this shape. So I think for this shape, I'm going to use the cut it apart strategy. You could fill this in. You could draw this line here and this line here and make this a square, but I think I'm gonna try the cut it apart strategy first. So I'm going to cut my square or my shape right here. Now that's gonna leave me with 2 different rectangles. For this rectangle, I see that I've got a 2 and a 1. So we're not going to use this 4 because we know the 4 is from this point all the way to this point, and that's not what we're trying to find yet. We're just trying to find right here. So we've got a 2 and a 1. So 2 times 1, obviously we know that's 2. So inside this shape here, we know is 2. Okay, so moving on to the bigger rectangle. Now this is the one where we have some missing side lengths. So we're going to have to use what we have around it. We know that this side is 3. That's easy enough. Now to find this length here, we're going to have to use a little problem solving. So If I take this line and move it down, I know that from here to here has to be 2 because this is a rectangle and this side has to be the same length as this side. So let's pop that down there, 2 centimeters. So I know from here to here is 2 centimeters on this bottom line. I know that the whole line is 4 centimeters. So I need to find this little section here. Well, if 2 centimeters is here, to get to 4, this also has to be 2 centimeters. So now I know that the bottom and top of this rectangle is 2 centimeters. So that's given me the 2 that I need. I now know my columns and my rows. So 3 times 2, which we know is 6. So now I just need to add the area of both rectangles. So 6 plus 2, which is 8. And that tells me that the area of this whole shape is 8 centimeters. And don't forget that squared. Very important. Now for this shape, we could have just filled in this line here and gone 3 times 4, which might have been easier. 3 times 4 we know is 12, and then we have to just take out this little piece. So we know that we've got a 2 times, and we need to find this length. To find that length, we're going to look to this edge. We know that from here to here is 1 centimeter. So that means from here to here is 1 centimeter. And we know that the whole length is 3 centimeters. So this also must be 2 centimeters. So then we've got 2 times 2, which we know is 4. So now we have to subtract our 4 from our 12. So 12, 11, 10, 9, 8 centimeters squared. So you can do it both ways. Both ways you have to find a missing side length, so it's whatever you're most comfortable with. Okay, so attached to this assignment is another PowerPoint presentation that you're going to be able to click through and find the area for some wonky looking shapes. So none of these are going to be the perfect squares or rectangles we worked on yesterday. They're all going to look a little bit more like this. Some you'll be able to just count the square units, and some you're gonna have to try to do the math like we had just done. So you get to decide if you're going to use the cut it apart strategy or if you're going to fill in the empty gaps. That's 100% up to you and your own personal preference. Have fun with that, and we'll see you next time. Bye.